Hello, how are you? I hope that you are all fine today. This is Ms. Isra Saad from Science Team at New Generation Language School. Our session for today was about Unit 2, the atmospheric layers, Part 1. In this lesson, we are going to talk about the atmospheric envelope, atmospheric pressure, normal atmospheric pressure, and finally, how the atmospheric pressure changes by changing the height above the sea level. First, we will start with atmospheric air. The atmospheric envelope or the atmospheric air, it is a gaseous envelope surrounding the Earth that rotates with the Earth surrounding its axis or surrounding itself and extends for about 1000 kilometers above sea level. Don't forget that atmosphere rotates with the Earth around its axis as you see in this picture. And when we look around us, we can see many different things, and all these things are called matter. So any matter has mass, volume, and weight. So the atmospheric envelope has a weight, and this weight is known as atmospheric pressure. So now we are going to talk about the atmospheric pressure, and we'll start with the definition. So it is the weight of air column of an atmospheric height 1000 kilometer on a unit volume 1 meter square. And the atmospheric pressure is measured by a unit called bar or millibar. And don't forget that 1 bar equal 1000 millibar. And do you know that the atmospheric pressure at the sea level is known as normal atmospheric pressure, and it equals 1013.25 millibar. And so what is the meaning of normal atmospheric pressure? It's so easy. It is the atmospheric pressure at sea level. Perfect. And don't forget that the internal pressure in the human body equals the external atmospheric pressure. So, to show how atmospheric pressure changes by changing the height above the sea level, do this experiment. And you will observe that the change in the shape of yellow clay is the maximum due to increasing the temperature on it. And the change in the shape of red clay is a maximum due to the increasing the pressure on it. Brilliant. And our conclusion is the change in the shape of clay spheres increases by increasing the number of box or height due to the increasing in their weight or pressures, and vice versa. Perfect. We have here one question. Give reason the atmospheric pressure decreases on going above the sea level. No, so the answer is due to increasing the length of air column and thus its weight decreases. Another question. The atmospheric pressure increases on going under the sea level, so it's so easy due to the increasing the length of air column and thus its weight increases. Another question. The atmospheric pressure differs from an area to another on the Earth's surface. So the answer is due to the difference in the length of air column from an area to another on the Earth's surface. Super. And look at this picture. This is the relation between altitude or height above sea level and the atmospheric pressure. It is an inverse relationship. Don't forget that 90% of mass of the atmospheric air is present up to 16 kilometer height above the sea level as you see in this picture. And about the next picture, 50% of mass of the atmospheric air is present up to 3 kilometer height above the sea level. What happens to the density of air going above the sea level? The density of air decreases. It's so easy, think. So don't forget that the density of air at the top of mountain is less than the density of the top of the foot of mountain. So the density of air at the top and at the foot of the mountain. Look at this picture. And now we are going to talk about the instruments of measuring the atmospheric pressure. So the atmospheric pressure is measured by barometers, and it has two types. We have two types here. First, aneroid and altimeter. And about number one, it's used to determine the possible day weather based on the atmospheric pressure. And the other one, we have the altimeter. And altimeter have two types, analog and digital, and it's used in airplanes to measure the elevation of navigation based on the atmospheric pressure. And now we are going to talk about the atmospheric pressure maps. In the atmospheric pressure maps, points of equal pressure are joined by curved lines known as isobar. So from here we can get the definition of isobar. So it's curved lines that join the points which is equal in the pressure in the atmospheric pressure maps. And if you look at this picture, you can see two letters. I think it's there is letter H and the other letter is L. So the center of high atmospheric pressure areas is represented by H, and the center of low atmospheric pressure areas is represented by L. So now we're going to talk about the importance. The atmospheric pressure maps are used to detect the directions of winds. Give reason: because winds move from the area with a high atmospheric pressure to the area of low atmospheric pressure. And we have here question, give reason. Winds moves from an area to another on the Earth's surface. I think the answer is so easy due to the difference in atmospheric pressure from an area to another on the Earth's surface, where the wind moves from the area of high temperature of high atmospheric pressure to area of low atmospheric pressure. And I think that's enough for today, and thank you so much. See you later. Goodbye.